Welcome to yet another episode of our lessons in trigonometry, and today we are exploring inverse trigonometric functions. I'm Wokwesi Gabriel Nelson Amoti, and my WhatsApp contact number is displayed on our screens, and I'm here to assist you achieve your best while me and you embark on this journey. We are coming to the evening of our topic. We have so far discussed almost 90% of trigonometry, and we are almost coming to the evening of it. Make sure that if you have missed the previous lessons, you go back and replay them on our channel, and where you need to consult or to know something, you can still inbox me on WhatsApp or give me a direct call. Inverse trigonometric functions. If tan A is equal to x, then it is okay to say that A is tan inverse of x. And if cos B is y, likewise we can say B is cos inverse of y. And if sin C is z, then C is sin inverse of z. Now this inverse function should not be confused with the reciprocal of trigonometric functions. For example, 1 out of cos y is sec y, but not cos inverse of y. So these two are different things. The reciprocals give us sec, cot, cosec, and so on. But these inverse are actually inverse fractions that get us, obtain for us the angle when we are given its trigonometric function. Now, to understand inverse trigonometric functions, we just need to have understood the previous lessons that we had. We shall basically be applying them along the way. Allow me go straight to the example so that we can further our understanding in these concepts. Example number 1 says, show that 2 tan inverse of x is equal to tan inverse of 2x over 1 minus x squared. Now, we shall begin from our left-hand side. On the left, we have 2 tan inverse x. What if we let that tan inverse of x to be an angle, say, A, which means 2A now becomes tan inverse of 2x plus 1 minus x squared. Now, basically, that is what we want to show. How do we proceed? After setting our A as tan inverse of x, we shall introduce now, since here on the right we have tan inverse, which means we are going to introduce here tan. So tan 2A, if you have tan inverse on the right, introduce a tan on the left. If you have cos inverse, introduce a cos on the left. If you have sin inverse on the right, introduce a sin on the left. So tan 2A, using what we already know, this becomes 2 tan A, using a multiple angle knowledge, 1 minus tan squared A. But now from here, if we let tan inverse of x to be A, then tan A is equal to x. So wherever we have tan A here, we shall put x. So tan of 2A is equal to 2x out of 1 minus x squared, which means our 2A is tan inverse of 2x out of 1 minus x squared. But what was our A? Our A was tan arc of x. So 2 tan arc or tan inverse of x is equal to tan inverse of 2x out of 1 minus x squared, and we have derived our expression which we are supposed to show. So as required. Then for number 2, now we have sine arc of a half is equal to cos arc of root 3 over 2. As it was done before on the left, we shall let our sine inverse of a half to be, let's say, angle A, such that sine A is a half. Now remember, we have on the right we have cos inverse. Okay? So here we have sine inverse of a half, which we call the A. Now since we have cos inverse on the right, I said now introduce cos. So cos of A, now in terms of what we have, in terms of sine, it will be the square root of 1 minus sine squared A. Okay, square root of 1 minus, but sine A is what? Sine A is a half squared. So cos A becomes 1 minus a quarter is 3 quarters. 3 quarters square root is root 3 out of 2. So cos A is equal to root 3 out of 2. I think I'll dry cell in the pen. The time just sorry, just a moment. So what is our A? Our A is now cos inverse of root 3 over 2. Therefore, if we put back our A, since our A was sine inverse of a half, therefore sine inverse of a half, which is A, is cos inverse of root 3 over 2. And as my pen has an issue, the dry cell is getting finished. So that is the required proof. Now, as number 3, show that tan inverse of a quarter plus tan inverse of 2 over 9 is equal to tan inverse of a half. We shall still begin with our left. Let each of them be some given letter. I'm saying let, now I will say tan inverse of a quarter to be P, which means tan P is a quarter. Then we let tan inverse of 2 out of 9 to be Q, which means tan Q is 2 out of 9. Now on the left, we have P plus Q. Now, since we have tan inverse on the right, we introduce tan. Tan of P plus Q, you shall have tan P plus tan Q out of 1 minus tan P tan Q. Now, when we substitute in the values of tan P is a quarter, tan Q is 2 out of 9, then 1 minus a quarter times 2 over 9. Now, this whole thing will reduce to a half when you simplify it. Now, that being a half, we can therefore say tan P plus Q is equal to a half, which means P plus Q is tan inverse of a half. But we know what P was. P was tan inverse of a quarter. Q was tan inverse of 2 out of 9. Which is now equal to tan inverse of a half. That is the original thing we're supposed to show. Therefore, we have shown it as required. Let's go to question number 4. Question number 4 now isn't asking us to show, but is asking us to find the value of x such that tan inverse of x plus tan inverse of 1 minus x is tan inverse of 4 over 3. But the procedure is almost the same. We shall begin from the left and we let A to be tan inverse of x. So x becomes tan A. B to be tan inverse of 1 minus x. So that 1 minus x becomes tan B. Since on the right there is tan inverse, we shall think of introducing the tan on the left. So tan of A plus B. Now I'm on the left because this is A, that is B. Tan of A plus B is tan A plus tan B over 1 minus tan A tan B. So we shall have x for tan A plus 1 minus x for tan B out of 1 minus x times 1 minus x. Now, if we introduce tan, that is the left, also on our right hand side, since we shall also introduce tan on the right hand side. So tan of tan inverse, tan of tan inverse of 4 over 3, then gives us 4 over 3. These two will neutralize one another. Now, we can now equate the two. Left hand side equal to right hand side. So this x goes with the x. You have 1 out of 1 minus x plus x squared is equal to 4 out of 3. Now the two sides have been equated. Now since the two sides have been equated, we can now easily simplify our work. See what we get from there. By cross multiply, if we cross multiply and rearrange, we end up with, I'm leaving that to you to do the simplification. You get 4x squared minus 4x plus 1 is equal to 0. Now when you solve that equation with whatever method you can feel comfortable with, either completing squares or using the formula or factorization, you'll end up with x having a repeated root of a half. So in this case, x is equal to a half. Please, in your own working and write up, try to include as much as possible the entire working from the start up to the finish, including the steps which I have been able to skip there. Our last example, math is by doing. Don't expect to watch just and get things like as if you're reading a novel or something. You have to put in your hands, write something down. Question number 5. If tan inverse of 2x plus tan inverse of 3x is equal to pi out of 4, find the value of x. Still, what we shall do is we shall let, as usual, a to be tan inverse of 2x, which means our 2x is tan a. Let b to be tan inverse of 3x, which means our 3x is equal to tan b. So we have a plus b being, this time we don't want to do each side alone, we want to do them concurrently. A plus b should give us pi out of 4. Then we introduce now tan. Since we have tangents only, we can now even if we don't have the tan inverse on the right, but what we have up there is tan and tan. In addition formulae, we can only use these tans in tan A plus B. So we introduce tan A plus B is equal to tan pi out of 4. Here we shall have tan A plus tan B out of 1, take away tan A, tan B. This will give us 1. Tan pi over 4 is 1. Something back we talked about radians and degrees. Now, tan A is 2x. Tan B is 3x. Out of 1 minus 2x times 3x is equal to 1. Here we get 6x out of 1 minus 6x squared is equal to 1. Now we solve that question. And we end up with the 6x squared. When we simplify, 6x squared plus 5x. Please do this. Make sure that you see where it has come from. You can pause the video and put in the missing steps to reach here. Then we shall solve for x using any of the methods, either factorization, either formula method, completing squares, whatever is simplest for you. And we shall have the value of x as 1 out of 6, or x is equal to -1. So that marks the end of our lesson on inverse trigonometric functions. Get time and try to search for more questions, or if you want questions for practice, you can still inbox me and I share with you the questions. You can as well, if you contact me, we can make an arrangement giving you questions you try, as I also mark your work and correct where possible.